Hi, I'm BrendaEM. I'm going to explain how I make my semi-precision pinholes. And pinholes like this could be used in cameras, like pinhole cameras, and like if you make it with an oatmeal box or something like that, or if you have a Holga camera. And but I need a double pinhole for an optical experiment, and they don't usually have stuff like that on eBay. So have been experimenting and trying to find better ways to make them myself until I can afford some commercially. So I start off with brass shim stock, probably like a lot of people, and this is pretty cheap. This package was like $4, and it comes in various thicknesses. And I tend not to like it too thin nor too thick. And this piece here is let's see, what do we have here? Is 0.08. Get that in the camera. 0.08 millimeter, or point or 3 thousandths of an inch, and so it's not too thin, it's not too thick. It's like a thick sheet of paper. And I tried cutting it with an X-Acto knife, and I'm sure you can get a good cut, but I find it easier just to cut it with scissors, and these aren't even sharp scissors. If you have a good cutting board, it would probably be good, and if you used a real good square, that would be good. And for now, I'm just gonna eye it and snip off a section with the scissors. During this process, I try not to fuss with any given one piece, because this is kind of a trial and error process. It's hard to work manually with small precision things like this, and I usually cut more than I really need, and then I find out I need them. So I've cut some little pieces like that, and these are probably about 8 to 10 millimeters by about 20 millimeters, or about a little more than 3/8 of an inch by 3/4 of an inch. So I cut some little pieces, and I did get one tool, and this is a handy one to have for this. This is a pin vise, and basically this one's called the Pro Edge, made in USA. I like that. So you can take a needle and put it in it, and it really clamps on the needle, and it's got a little turny handle on the back, which comes in handy. And this is just a sewing needle. And what I also do is I get little pieces of sandpaper, and one of these is 600, and I suspect the other one is 1,000. I got little pieces of sandpaper, and I glued them using onto the glass using 3M adhesive. And before I glued them on, I cut the glass. I made sure it was non-tempered glass, because you can't cut tempered glass. And then I took a piece of wet or dry paper like this. This is silicon carbide wet or dry paper. And I sanded the edges just to break the edges so I don't cut myself. And because I'm doing this as a really delicate procedure, then I'm not, being rough on these. But if you don't feel comfortable working with glass, you can find like a scrap of metal or something like that to put on it. But for a lot of purposes, glass is really flat, and it's not totally flat, but it's a pretty flat thing, and it's hard, and it's unyielding, which is good. And I try not to put it on a table, but so I put I have a little piece of this is mat board, and this was mat board scrap, and some framing person or framing shop threw out a whole bunch of this stuff, and I guess once it gets to a certain size, they can't use it. You can also buy it, but I had stacks of it, and I made a lot of templates with it, and I try to make do with what I have, because that's all I have sometimes. So I've got a scrap of cardboard. I've got a little piece of glass with, in this case, a 600 grit piece of sandpaper, silicon carbide wet or dry, and I have a pin vise with a little needle in it. And what I try to do is sharpen up the needle and make it smooth. Basically, I kind of draw it to me. Keep even pressure, and just try to make it nice, and give it a few turns. And I try to do it diagonally, because I want it to be smooth going all the way. I want it to be smooth going this way as well as going around. And sometimes I do this in my hand. Here's the 1,000 piece, And you don't have to be totally precise about it, because and just be consistent. If you're consistent, it'll probably come out better than if you're really sweating over every single time. And that's how I sharpen up the needle. Excuse all the wires, but I'm fortunate to have on extended loan and a binocular microscope, and that makes it easy to look and see how the needle and the pinholes come out. And if you don't have a binocular microscope, you can get a little pocket microscope, maybe from Amazon or something like that. And sometimes surplus shed. Sometimes they have little monocular microscopes, and it doesn't have to be binocular, but it helps. And this has a built-in light, and but I sharpen up the needle and take a look at it through this. Through the microscope, you can see it's pretty pointy. If you look in the background here at the top, those are millimeters. So this is fairly pointy. So I got one of my little rectangles cut out of brass, and I'm just darkening it, blacking it actually with a magic marker. And the reason why I'm doing that is so after it dries, I can scribe a line on it and see what I'm doing. Resisting the temptation to use the needle I just sharpened, I'm going to take a straight edge, and I'm working upside down, so I'm trying to do the best I can. And I'm trying to just make a parallel line across the black line I did. I don't want to make this too hard because I don't really want to deform the metal, because it'll cause diffraction. So I've got the ruler just over the little piece of brass, and I'm using the ruler mostly as a guide. I'm still honoring the line I have on here, but I'm guiding it off of the ruler. And I think I'm going to try for, this is hard to do from far away, I think I'm going to try for about like a millimeter and a millimeter and a half. I'm just pushing it through and giving it a little turn. And about a millimeter and a half. This is very imprecise. It's also it's a trial and error process. And this part of it isn't much different than the traditional way of doing it. And once I get my two little dots there, I can flip it over and take a look at it. You can see there's two little dots there. And I'm hoping this is not too wide. And now I'm going to look at this in the microscope. And what I want to first do is get them the same size. So looking through the microscope, the holes are actually pretty fairly. This is hard to do looking through the camera, but this one's a little wider than this one. I've totally tilted it. I've gone off the thing, but the thing I don't like is I've pushed too far, and I've dented it too far. So let's try again. I taped the little brass piece down onto the cardboard, and I'm trying to get this so you can see it too, which is not so easy. It's not so easy for me to see it too. And I'm going to use, let me make sure we're in focus. I'm going to use, I want about a millimeter and a half, which is about a 1/16 of an inch. And so I'm going to try that and just give it a little turn to get it to go through. And I make my second one. Trying to keep the same angle, which is really hard. I can turn it a little bit, like so. Actually, that doesn't look too bad. You can see there's a big scratch there leading up to it right there. There's a scratch leading up to it. There's a hole here, and there's a hole here. But the holes are more drilled than punctured, which is what I wanted. The backs are still have excess metal hanging off of it. But this is a decent start. What I want to do now is drill them each about the same. The one on the left a little bit more than the one on the right. And then I'll take another look at it. So I evened them up pretty much. And for comparison, there's a strand of my hair on the top. And My hair is about a thousandth of an inch. Most people's are about 2/1000ths of an inch. Mine is about a thousandth of an inch. My mom had really fine hair too, and that's a good place. I want to make one that's about this size, and I'll make one that's a little bit bigger than that. But this looks pretty good. So I don't think it's imperative that you have a binocular microscope, but I do think it's imperative that whatever microscope you have, whether that it be supported, because it gives you, and they have plenty of light, because it gives you an advantage. Let's see if I can get in here and still let you see this. The advantage that it gives you is that if you start a hole, it makes it easy to find where you're at and continue to make the hole larger like that. And I can just I can almost look through here while I'm doing it, but if I do, that means I'll be making the hole on an angle. So this is the nature of the thing. And these I want to make a little bit bigger. And you can't see what I'm doing through here, but you can see I'm trying to hold this pin vise totally perpendicular to the surface, and these are going to come out bigger, and like so. Once again, I'm trying to do more drilling than put pressure. There's a reason for that. As you're doing this, most of what you're doing is displacing metal. You're pushing it out the back, and it has to be controlled. It's not like drilling a hole. Not most of it, anyhow. I wish it were more like drilling a hole. And once again, if you just need a single pinhole now, you can find them on eBay for a decent price. But for something like this where you need two, it's not so easy. And it's fairly easy to get back right in the hole without even scratching the edge of it much. And that's about the right size. These are actually closer than the previous ones. And this is, like I said, a pretty much a trial and error process. And you'll come up with some that are good and some of them that are not so good. Hence it being a hobby and not a profession. Like that. And I'll give you a look at this. So this is what I have. And this one's, the holes are larger, and you can see I've got my strand of hair going across it. These holes are probably about this one's probably about 4.5 thousandths of an inch, and I wish I knew metric like that, but I still don't know it yet like that yet. And this one's a little bit smaller, but that could be touched up later. You can see how big the dust is. This other strand that's much finer is the strand from the black carpet you always see in my videos. So they don't look that bad from this side, and they're fair. And what I was trying to go for is get them fairly even and try to make them as best I can through drilling instead of puncturing. But in spite of how hard you try when you're doing this, I'm going to take it, and I'm going to slide off the edge of the microscope, which is not easy with one hand. If I get this in the center, you can see clearly that it has puncture marks on the other side. And what I want to do is remove those. What I want to do is get rid of the metal, leaving this without this thing, because this will cause all kinds of diffraction. Well, this basically just the purpose of this thing is to cause diffraction anyhow, but this gets really ugly. So I have my little 600 grit. This is silicon carbide sandpaper, wet or dry, and it should be wet or dry. Basically, almost any place that has auto parts will have sandpaper like this, and hopefully individually. And this is a little worn, but it still should work. And I've got it just glued on the back of a piece of glass, as I said. And I could put a couple of drops of just a little water on here. And I think we could start this off with 600. So I just turn it, flip it over, and very gently, you don't want to press on it too hard. Just fairly gently rub it across. And what I'm trying to do is grind off this right here. And you don't want to go crazy with it. And after a while, it should move a little bit easier. If you're doing a lot of stuff like this, or a little wet sanding like this, you can put just a drop of soap in it, but not too much. And I don't know if you can see that, but you can see that it's dull now. And now let's look at it again in the microscope. And this apparently is 37.5x, and you can see just that little bit of sanding removed it. And I think I'm going to hit it with 1,000, just a little bit, and then I'm going to hit it with some of the polishing compound. But that looks pretty good. And then 1,000, I just put a little water on here. Actually, if I had a little bit of soap, that would work a little easier. And I just polish it. At this point, I don't want to do much. I can try to do the other side, but I'm not confident that it'll actually help, because the other side is pushed in a little bit. And as you can see, it's hard to get in there. Well, let's take a look at it now. Actually, I'll give it one more go. This is after the 1,000 grit. It looks pretty good. I mean, I just wanted two holes that were very close together, or about the same size. Oddly enough, nothing in this box is illegal, although it doesn't look like this way. This is aluminum oxide, and I believe this is 12¼ microns. This is cerium oxide. That's too fine for what we want to do. This is headlight repair, headlight lens repair stuff. This is aluminum oxide, 5¼ microns. This is valve grounding compound. This is too coarse. This is also that. This is 600 aluminum oxide, 600 grit aluminum oxide. I don't know how big that is in microns. This is 9¼. And what I'm going to do is mix up some of this with some water on a little piece of glass, and I'm going to use that to grind the extra metal off the back. If you don't have, I mean, this stuff is, you don't find this everywhere. If you don't have this chrome, something like rubbing compound, a mixture of that, of its water soluble, and water might work. Certain kinds of toothpaste might work, but if you're using toothpaste that'll do this, maybe you should look for a different brand. Also, chrome polish might work if it's water soluble. But water soluble, you really need something water soluble, because otherwise you're going to be working with like turpentine or spirits or alcohol, and that's going to make things harder. So I have a little piece of glass, and I tend to round the edges on this, on these, and or at least be very careful. There's no sense in cutting yourself, and you should, if you're a kid, you shouldn't be doing this without your parents' supervision. And I take a little bit of this. Probably don't even need that much, and a couple drops of water. Actually, maybe a finger would be good. As if I had an eyedropper. And I tried to find eyedroppers. It's not so easy. And stir it up. And then I take one of the things, and I flip it over, and just gently keep on rubbing it. Here you can see the ground surface on the other side. The streaks, or most of the streaks from the sanding process, are gone, and we're just left with a really textured surface. The other side, we can see that the polishing or the grinding on the other side did everything that other than what we wanted it to. And although it might be possible to get something soft, I might try it with this one. I might try getting something soft and try polishing this up with something soft. Maybe an eraser will be enough of a kind of a backing thing. I tried an eraser and some 600 grit. And once again, it seemed to took off a little bit of the marker, but still, the area I want to get at, that which is closest to the hole, is still rough there. You can still see that little bit of ridge, and I can't quite remove it. This is one of the others. I didn't try it on one of the good ones, so there's probably a way to do this, but I don't know. basically maybe some kind of cone countersink, but that would probably be getting beyond what you could do, with home. Maybe a wider needle or something could do it, and but then you have to worry about changing the size. So this part of it was a flop. Over the course of about a half an hour, maybe 45 minutes, I made two pinhole plates, and this one's, they're about 4/1000th of an inch, and these are close together, and these are farther apart, and that's actually some kind of circular scratch I put in it. And let's look at the other sides. As you can see, I was unable to grind it on that side. And I was unable to grind it on that side. Oh, when I use a countersink, that's maybe 4 times as big as your hair. And there are ways to blacken these. And I think Birchwood Casey makes blackening stuff, but it's not cheap, and it's awfully toxic. And Magic Marker might work. I might experiment with that because it can be removed. I might give that a shot. And so if you were making like a camera one, they're much larger, and so they would come out proportionally a lot better. For instance, the holes in this are probably would be an F. Maybe if it was a camera, it would be like an F128 or something, or F1 256 or something. And if you were making like a maybe a 1.5 millimeter hole, you can polish it pretty well like this. In SAE, these are bigger than I thought they would be, and they're 0.015 of an inch, so it's more than 1/100th of an inch, so they're bigger than I thought they would be, and bigger than the ones I made last time. So I'm glad I made a smaller ones too. I wanted to give you a peek at what I wanted the double pinhole for. And I have one of the double pinholes just clamped into one of these soldering third hands. I have a little piece of scrap brass here holding it so it doesn't get deformed. I have the lens out of the way. And on this side I have, it's a 10 milliwatt red laser. And it's about twice as bright as a laser pointer. And you have to be careful with lasers, anything brighter than a laser pointer, and you shouldn't point lasers at flying helicopters and planes and stuff, because it's wrong and it's dangerous and people could die, and it also ruins it for the rest of us. If you don't want helicopters flying over your house, I suggest that you write letters to the Federal Aviation Administration instead. And 10 milliwatts is twice as bright as a laser pointer. And it's probably easily strong enough to damage your eye, if not cause blindness, at least temporarily. I like the old laser saying, "Do not look into laser with remaining eye," and it's very ominous, but I think it's an effective saying. So this is just a little box, a little tiny, cute little console cabinet, and it has a little more in here than a voltage regulator and a couple capacitors. And on the other end of it, plugged in over there, there's an old cell phone charger putting out 5 volts, and it gets dropped down to 3.3 in here. Laser diode claims it wants, driver wants 3.2, which is unlikely, but still. Anyway, let's turn this on. And I went off of adjustment, but that's how things are when you're doing this kind of rickety demonstration. So I've got the laser now pointing, so it's going through both pinholes. And down further on my bench, you can see way down there that it's hitting a little piece of white plastic, which was pulled out of a flatbed scanner. These little plastic things make great little targets for things like this. And let's get a little closer and take a look at it. So I've moved you down along my bench, and I've centered it. We're a little on an angle, unfortunately. I don't have a little tripod, but you can see that the spot is still in the center. Now let's pull the lights. And if you look carefully in the center, that you can see there's little rings forming or formed around the two little spots, and that's caused by interference. And some of it is from the diffraction from the light, going in a wave function around the metal or touch around the edges of the metal, and some of it is probably from the light interfering with itself. And in an upcoming video, I'll elaborate on this.